A rectangular concrete beam has a width of 300 mm and an effective depth of 550 mm. The beam is simply supported over a span of 6 meters and it used to carry a uniform dead load of 20 kN per meter and a uniform live load of 40 kN per meter. So, including the weight of the section, so under yun sa dead load. Okay? And the specified compressive strength of 21 megapascal and Fy of 312 megapascal. Compression reinforcements, if necessary or if it is needed, should be placed at a depth of 80 mm from the outermost compression concrete. Determine the area tension steel area using NSCP 2015. Okay. So for this problem, meron tayong base width na 300 mm. And then, yung ating effective depth is 550 mm. The beam is simply supported throughout its span of 6 meter, carrying a dead load and live load throughout its span. So, buong span ng 6 meter is distributed yung mga loadings natin. Okay? And then, weight of the dead load, including its weight, so self-weight of the section, is 20 kilonewton per meter. Then, weight of the live load is 40 kilonewton per meter. The specified compressive strength of concrete is 21 megapascal. Since the section or the F prime C is less than 28 megapascal, therefore we can say that the beta 1 factor is equivalent to 0.85. Next, our specified yield strength of steel is 312 megapascal. Okay? And if needed daw yung ating reinforcement sa compression side, so assuming dito siya, it should be located 80 mm from the outermost compression concrete. Determine the required tension steel area using NSCP 2015. Okay, so after the required is AS, or kung ilan bang area yung steel reinforcement na kinakailangan for this type of loading and this type of section. Okay, so for the solution, first, compute muna natin kung ilan ba yung loadings na kakargahin ng ating section. Okay? So, so in order for us to compute the value of the ultimate load that the beam could carry, or simply WU, we have to factor muna natin yung mga dead load natin and live load, since ito ay mga unfactored pa sila. Kumbaga, hindi pa na-multiply sa mga load combinations sa ating with regards sa NSCP 2015. Okay? So first, kunin muna natin yung uniform loadings, ultimate uniform loads. So includes dito yung dead load at saka live load. So we have 1.2, since W yung pinag-uusapan natin, W din yung consider natin. So 1.2 W dead load plus 1.6 W live load. Okay, this is the load combinations according sa NSCP 2015 if meron tayong given na dead load at saka live load. Next, we have to substitute those value. We have 1.2 dead load of 20 kilonewton meter plus 1.6 of live load of 40 kilonewton per meter. Okay, we have the value of for WU of 88 kilonewtons per meter. Ito yun na yung kakargahin ng ating section. So, in-indicate dito sa problem na yung dead load, dead load is including its own weight. So, since sinabi na dito na including the weight of the section, there's no need to compute the loads due to the section. Kasi sabihin nga dito is kasali na yung kanyang self-weight. Okay? Sa 20 kilonewtons per meter na dead load. Okay? Kasi if hindi indicated sa problem, let's say for example, excluding the weight of the section, kailangan pa natin i-multiply or kuhanin yung timbang ng section natin using the unit weight of concrete. Okay? So, since for this problem is in-indicate naman that it includes the weight of the section, there's no need to do yung compute yung self-weight. Okay. Next. For our second step, we have to compute the maximum moment with respect to the ultimate loadings to be carried by the section. So since this type of loading is uniformly distributed throughout its span and it was again simply supported, we have a direct equation regarding those considerations, which is W, since pinag-usapan natin is U or ultimate, so ultimate din yung consider natin. And length is the length of the beam, L squared over 8. Okay. If you are not familiar on this general or specific formula for this type of loading, you can construct its shear and bending moment diagram in order for you to get the maximum or the ultimate moment that the beam could carry. Okay? So, yun. If hindi nyo alam itong formula, pero I suggest that you familiarize this specific equation dahil gamitin siya sa mga different design subject natin. Okay. Third, after natin ma-compute yung uniform load at the same time yung maximum moment, so ito pala 88 kilonewtons per meter multiplied by the length of 6 meter, naka-square siya, divided by 8. Our ultimate moment is 396 kilonewton per meter. Okay. After ma-compute si WU, si ultimate moment, next thing that we can consider, i-check natin kung yung section ba natin ay singly reinforced beam or double reinforced beam. Okay? Dahil wala tayong assurance that this problem is a singly reinforced beam type problem, plus dinagdagan pa dito, sabi niya, compression reinforcement if necessary, kung kinakailangan daw. So, ibig sabihin, kailangan muna natin siyang i-check kung ito ngang problem na ito is singly reinforced beam or doubly reinforced beam type problem. Okay? In order to double check if SRB tayo or DRB, kailangan i-compare natin yung reduction factor ng maximum, okay, versus sa MU natin. Okay, so kailangan muna natin i-compare yung maximum moment versus the ultimate moment. Okay, so for the maximum moment, we have a formula, reduction factor 51 over 140 beta 1 f prime c bd squared quantity 1 minus 3 over 14 of beta 1. Kumbaga, i-check muna yung maximum, yung pinaka-max. I-compare natin siya sa computed ultimate moment natin. Okay, so given na si beta 1 f prime c and the section itself, given na din siya. So yung wala na lang natin dito is yung reduction factor. Okay, and as we all know, if maximum condition yung kino-consider natin, the tensile strength of steel reinforcement under maximum condition is amounting to 800 megapascal. Okay, so Fs max is 800 megapascal. Okay, so we have to compute for the reduction factor. We have 0.65 plus 0.25 quantity Fs minus Fy over 1000 minus Fy. This is the strength reduction factor formula. Next, substitute the parameters. We have 0.65 plus 0.25 quantity under maximum condition. 800 is our tensile strength minus Fy na 312 megapascal. Then 1000 minus 312. Our reduction factor is 0.827. So ito yung i-multiply natin for this equation para malaman natin yung maximum design moment. Okay, so going back to this equation, dahil meron na tayong reduction factor, so maximum design moment is equals to reduction factor of 0.827 quantity 51 over 140. So reduction beta 1 factor natin 0.85 dahil yung f prime c natin is 21 lang. Okay, yung f prime c natin na 21 plus base na 300 by 550. 300 by 550 squared quantity 1 minus 3 over 14 multiply by 0.85. So yung acting maximum design moment is, so since mga given natin dito sa mga naka-millimeter, so definitely yung units niya dito is naka-Newton millimeter. So 0.827 multiply by 51 divided by 140 multiply by 0.85 times 21 times 300 by 550 squared quantity 1 minus 3 over 14 of 0.85. Our moment is 399,125,940.70 Newton millimeter. Okay? So, since yung ating ultimate moment is naka-kilonewton meter, so it is suggested or recommended to convert this into kilonewton meter. This one is millimeter. Okay? So, if in every 1 kilonewton, we have 1,000 newton. So, cancel na yung newton. And then, in every 1 meter, we have 1,000 millimeter. So, cancel na din yung millimeter. So, natitira kilonewton meter. Or simply, divide this answer ng 1 million. So, yung ating maximum design moment, yung MN max is 399.125 kilonewton meter. Okay? So, meron na tayong maximum moment na 399.125. Ngayon, yung ating ultimate moment that the beam could carry is only 396 kilonewton meter. So, mas malaki pa din yung maximum. Kaya kumbaga, nasa pagitan pa din or nasa loob pa din ng maximum yung ultimate moment natin that the beam could carry. So, therefore, if MN max is greater than sa MU, therefore, it is SRB. Hence, if rho MN max is less than MU, ibig sabihin kulang pa siya, DRB tayo nun. Okay? So, since in this case, mas malaki yung ating max over MU, so yung ating section is SRB. Singly reinforced beam siya. So, wala pa tayong masyadong concern sa compression reinforcements niya dito. Okay? So, first, let me repeat, compute the WU, that will be the ultimate moment. Next, compare it with the maximum design moment. Okay? And kapag mas malaki yung max versus sa ultimate moment, yung type of problem natin is singly reinforced beam. Hence, if mas maliit naman yung maximum compare sa MU, ibig sabihin kulang pa yung moment na kayang kargahin or i-resist ng ating section, doble reinforced beam tayo. Next, after natin makuha yung mga moments, compare it to determine if it is SRB or DRB, next thing naman na consider natin, i-check na natin siya if tension control siya or not. Okay? So, fourth step, solve for moment due to tension controlled. Okay. And on this consideration, we assume that the reduction factor, since tension controlled, assuming yung reduction factor natin is 0.9. Okay. However, we have a direct formula na 459 over 1,600, which is derived based on the principles of 0.85 F prime CEB, quantity D, A minus 2. So, galing din ito doon. Pero, for the sake of simplicity of the various parameters, the author of the reference book I use ay sinimplify na niya into this equation for tension control. Okay, o kumbaga tension control determination, i-check natin kung tension control ba siya or hindi. So going back, 459 divided by 1,600, beta 1, kung halos para-pares lang naman sila yung mga previous moment formulas, nag-iba lang sa kanilang mga numerical coefficients. Okay, so beta 1 f prime c b d squared quantity 1 minus 3 over 16 beta 1. Substitute this value mn t is 459 divided by 1,600. What is this? 0.85 f prime c na 21 megapascal, base of 300, and an effective depth of 550. Quantity 1 minus 3 over 16 times 0.85. So yung ating tension controlled moment, okay, we have mn 459 divided by 1,600, quantity 0.85 times 21 times 300 times 550 squared, quantity 1 minus 3 over 16, then 0.85 we have. So for simplicity, convert na natin ng 1 times 10 raised to 6 para maging siyang kilonewton meter. Divide 1 million, 1,000. We have 390. We have 390.642 kilonewton meter. Okay, so i-compare natin siya versus sa mu. Okay, so if mnt natin is greater than mu, kumbaga mas malaki na yung ating tension controlled moment. Okay, ibig sabihin tension control talaga tayo, tension control, and automatically our reduction factor is 0.90. Next, if our tension moment or tension controlled moment is less than 2 mu, kumbaga kulang pa versus sa ating mu or the required moment or the ultimate moment that the beam could carry, under pa tayo sa transition region. And reduction factor can be computed using (0.65 plus 0.25 quantity fs minus fy over 1,000 minus fy. So since ang ating tension controlled moment is 390.642 and yung ating mu na 396 megapascal, 396 megapascal, 396 kilonewton per meter, mas malaki si mu, so therefore we are on transition region. So for this checking, we can simply say that if malaki yung ating tension control moment, compare sa actual, kumbaga actual na kakargahin ng ating section which is MU. So definitely, kumbaga sobra-sobra siya. So tension control na tayo nun. However, if kulang or if M and T is less than compared to MU, nasa transition region tayo nun. So yung reduction factor is 0.65 plus 0.25 Fs minus Fy over 1000 Fy. Okay. Since sa transition region, wala siyang indicated kung what type of tensile strength yung magagamit. So, we can compute the value of tensile strength. Okay. Using the formula 600 quantity effective depth minus the distance from the neutral axis over C. Okay. After we verify various parameters from WU, ultimate moment, capacity, okay, and after natin ma-check if ito by singly reinforced beam, and then eventually na figure out natin that this section or this type of problem, yung kanyang reduction factors under siya sa transition region, at least we can compute already the value of the steel reinforcements. Okay, so in order for us to determine the AS, kasi sa AS we can solve it using if we compare the compression over the tension. Okay, however, before we do that, we have to first determine the various variables such as the depth of the compression block, distance from the neutral axis, tensile strength of concrete, or tensile strength of steel reinforcements, and so on. Okay. So we can compare it by the actual moment capacity or MU, ultimate moment capacity. Ito yung it is the ultimate moment. Okay, MU is equals to reduction factor 0.85 F prime C AB quantity D minus A over 2. So kumbaga ito yung one of our general equations throughout our discussion. Okay, we compare it. So ikukuha na natin si distance from the neutral axis muna, and then si depth of the compression block. Okay, and eventually makukuha natin na yung area of steel reinforcement. Okay, so if our ultimate moment is 396 times 10 raised to 6, so tinraise na natin to raised to 6 dahil naka Newton millimeter naman tayo dito. Next, for the value of strength reduction factor, we have first, we have 0.65 plus 0.25 quantity Fs. Since Fs natin wala siyang given, so i-substitute natin this value or this equation 600, effective depth of 550 minus the distance from the neutral axis over C minus Fy natin ay our Fy is 312 minus 312 over 1000 minus 312. Okay, kumbaga this initial values for reduction factor only. Next, multiply this 0.85 times f prime sin 21 quantity, the depth of the compression block. Since meron na tayong variable c, might as well change this the distance from the depth of compression block in terms of sa kanyang what do you call that, sa kanyang neutral axis distance. So we have the depth of the compression block is beta 1 or beta 1 factor multiplied by the distance from the neutral axis. So substitute 0.85 C. Okay, since wala pa tayong value ng C. And then for the value of base, we have 300. And for the depth of compression, effective depth is 550 minus ito pa din, beta 1 factor na 0.85 C over 2. So, the value of the distance from the neutral axis, or C, is amounting to 224.083 millimeter. Kumbaga, ito daw yung ating distance from the neutral axis. Next, substitute. Next, A is beta 1 C, or that is 0.85 times C natin na 224.083. A natin ay 190.471. Since unit natin is ako millimeter, so yung depth of the compression block natin is also millimeter. Okay. Next, after we get this distance from the neutral axis, the depth of compression block, we can next compute the tensile strength based on these parameters given. So Fs is 600, depth of the compression block of 550 minus the distance to the neutral axis of 224.083 over 224.083. So galing ito dito sa equation natin dito. Next, for the tensile strength of steel reinforcement is 872.669 megapascal. Since it is greater than Fy, we can safely say that Fs is equals to Fy. Kasi mas malaki si Fs. Kumbaga, ito na yung pinaka-max niya. Kumbaga, and usually naman, di ba, given lang is yung Fy. So we can safely assume that if Fs is greater than Fy, for the design purpose or to the analysis purpose, Fs can be same or parehas lang sa Fy. Okay, again, if Fs is masyadong malaki compare kay Fy, pwede na natin gamitin si Fy na lang. Okay. Next, compute natin yung reduction factor. We have 0.65 plus 0.25 quantity Fs minus Fy over 1,000 minus Fy. So substituting this value, you have 0.65 plus 0.25 quantity 872.669 minus Fy natin na 312 over 1,000 minus 312. Our reduction factor is 0.854. Ito yung ating reduction factor. Next, after we compute the different variables needed, we can now assume or compare C compression is equals to tension, or 0.85 prime or 0.85 F prime C AB over AS Fy. So ginamit natin yung Fy dito due to this type of condition. So if Fs is greater than Fy, we can safely say that Fy is Fs. Next, yung target natin dito is si As. So divide both sides by Fy. The area of steel reinforcement is 0.85 F prime C AB over Fy. Substituting these parameters, we have 0.85 and F prime C of 21. Depth of the compression block is 190.471. That is for A. And meron tayong B na 300. And yung ating Fy is 312. So yung area of steel reinforcement needed is 0.85 times 21 times 190.471 times 300. We have divided by 312. We have 3,269.14 millimeter squared. Okay, so this is our area of steel reinforcement needed. However, okay, so if gusto natin na in terms of pieces, halimbawa, curious tayo, ilan bang piraso yung kinakailangan for this type of area of steel reinforcement? So number of pieces is equals to AS over A mas maliit na S. Kumbaga, yung total area of steel reinforcement natin, divide natin sa individual area of steel reinforcements. So we have 3269.14, assuming we want 28 millimeter diameter. So we have 0.25 pi times 28 squared. So number of pieces needed is 3269.14 divided by 0.25 pi times 28 squared. We have 5.31 or approximately 6 pieces of 28 millimeter RSP. Okay.